we are live now, folks. So, hey, folks, this is me, Vishwas Nayan. I'm the host of this webinar. Dapr has been one of the most celebrated open source softwares that we have ever come across because it removed the aspect of, you know what, let's not stick on to one tool, let's just figure out the ways to move around and let's be more agile than what we were agile back then. I think there is always a different definition for it. There's always a different form factor for it. I think Nilesh sir has been one of those people that I always look back at anything cloud native, and he's going to give you an deep introduction to how to deal with your production issues right now, and also some insights on how to use Dapr the right way. So thank you so much, Nilesh sir, for being on the show. Means a lot.
Thanks, Vishwas. So let's get started. Today we're going to talk about how to build portable multi-cloud microservices with Dapr. So before we get started, a quick introduction about myself. Who am I? My name is Nilesh Gule. I put my social media handles here in case you would like to connect with me. I'm a technical evangelist and I like the game of cricket. The IPL is coming up and I'm looking forward to it along with the Cricket World Cup. So if anybody is interested in talking about that outside of this event, I'm more than happy to talk about it. I'm also co-organizer of the Azure Singapore user group, and we conduct a lot of online sessions, or we conducted a lot of online sessions during COVID time, and all this is available on our YouTube channel. So if you're interested in learning about Azure and different things around Azure, feel free to subscribe to our channel. A bit of history where I started and what did I do. I was born and brought up in Goa. You might have seen some of these wonderful places in Goa in various forms. If you've visited Goa, you might have been to some of these very famous places. Otherwise, Bollywood is always in Goa shooting for these exotic locations. Uh, Typical thing about Goa is you will find it completely different to the rest of India because it was a Portuguese colony, unlike a British colony, and that's where there is a distinction in the architecture style of the buildings, the kind of food we consume, the way we talk, and things like that. So hopefully you will get a chance to travel to Goa and enjoy this wonderful place. Now, coming to today's session, we'll be talking about Dapr. But before I go into Dapr, let's see, why do we need a thing like Dapr, or what is the need for Dapr? I was recently doing this quick search, like what are the top 10 cloud providers in 2023 back in January. And I got this result saying it's the AWS, Azure, Google Cloud, the public cloud providers. We very well know that they are among the top 10. But along with that, there is also others like Alibaba Cloud, there is Salesforce, Dell, IBM, DigitalOcean, there is Adobe and Dropbox. So if you look at this spectrum, it tells us that it is not only the three or four public cloud providers, which are mainly around infrastructure as service or platform as service offering, but there is also things like Salesforce or Dell or IBM, which have their own products on cloud, and they are also seeing a lot of cloud adoption. There is Adobe, which is more of creative tools. They also have a lot of presence on the cloud, and something like file sharing by means of Dropbox. That also has quite a bit of potential. So, why do people move to cloud technologies? On the right, we can see some of the reasons or some of the benefits of moving to cloud. Cost is obviously one major factor why people move to cloud. Along with that, there are things like speed, which we get by having things like the self-service, pay-as-you-go options. We don't have to go through long, lengthy bureaucratic processes. We can spin up machines or VMs or even services using self-service options. And pay-as-you-go is another thing. If we are using these services and products for a short duration of time, let's say for only a week or only during month end or quarter end or year end kind of thing, then we can spin up these resources only for that short duration of time. We make use of those resources and then we can tear them down. So that's the another reason. Scalability is obviously one of the biggest factor where we can get on-demand resources very quickly and very efficiently. Automation plays a big role in this, and security and reliability. We know that cloud helps in various ways in terms of implementing better security policies. They have good technologies as well, like Most of the cloud providers, they provide AI and machine learning based threat detection and those kind of advanced capabilities, which might not be so easy for individual organization to build on their own. And the reliability in terms of, let's say, high availability and DR capabilities. All these cloud providers, they have their data centers spread across the globe. So for companies who are operating in different regions, or even for company which operates in one region but they want to have their disaster recovery capabilities in other region, we can use all these cloud capabilities. Along with the cloud adoption, what we are seeing is there is also a shift in the way we build application, and we are seeing more and more adoption for cloud native applications. These are different. There is a general misconception again when it comes to cloud native applications that these are the ones which need to be deployed on public cloud. That's not true. I would say those applications which can take advantage of things like the cloud computing innovations, they can take the infrastructure innovations, they can look at like auto scaling, they can be built on cloud native platforms like OpenShift or even Pivotal Cloud Foundry. These are the kind of applications which we can treat as cloud native. They don't have to be essentially deployed in the public cloud, but we can still have scenarios where they can be deployed on our own data center, and then for burst capabilities, let's say, they extend to the public cloud. These can also be deployed on the edge and as well as multi-cloud. Nowadays we are also seeing this trend that companies, they don't want to have a lock-in or tie up with one single cloud. So they are also considering multi-cloud scenarios. It could also be because of the regulations or compliance reasons, where one particular cloud provider might not have a presence in particular region, and for that reason the companies might have to use a different cloud solution or cloud provider in that particular region. So for these reasons, we see that the cloud native applications, they are becoming more and more of a standard, and there are some key characteristics required or associated with cloud native applications. These are typically built using microservices architecture. So we are no longer dealing with a big monolithic applications. We break down the big services or big application into smaller modular components, and they are deployed as microservices. These are also containerized, which helps us to have everything that is required for running the application packaged as a lightweight container image. And wherever the container runtime is available, we can deploy these applications. APIs are also quite popular nowadays. So instead of building point to point connections, we develop these as APIs, or we expose these as APIs, and they help us to build loosely coupled applications. And it also helps us to work with open standards. On the bottom, we see things like resiliency, scalability, and automation. So most modern day cloud applications or cloud native applications have this capability of self-healing, and they are resilient by nature, or at least they support features which help to make them more resilient. Things like self-healing, we can see most cloud providers, they have these capabilities where we can have multiple instances of the application running, and if something goes wrong, there could be a process in place which the cloud provider itself puts its own efforts and its own engineering things, where it can self-heal. When it comes to a platform like Kubernetes, again, there are capabilities which allow us to restart the applications in case of any problems and things like that. Scalability is not just in terms of right sizing, I would say. If we look at, let's say, historically, when we used to do the sizing of the VMs or sizing of our infrastructure, we would consider what is the growth factor in 3 years, 5 years, and 10 years down the line. And we would buy big servers. And in the end, we might utilize only maybe 10% or 20% of that resources. With cloud, what we get is we can use things like serverless, which allows us to provision resources just in time and only for the duration where it is required. And then we can scale back to the normal operations. Automation is all about what we have seen in last, I would say, decade or so. In the past, we still had CI/CD, or CI was prominent, like people were doing continuous integration, but continuous deployment has gained a lot of traction recently, and infrastructure as code, GitOps, these things are making automation more and more easier, and there are product services which make it very easy for us to start right from day one by having everything as code. Anything related to not just the application but also our infrastructure becomes part of our source control, and it is quite easy to maintain this. It is quite easy to have this automation capabilities right from the beginning. So these are some of the key characteristics of cloud native applications which make them more popular, and it also helps the cloud adoption. So for the purpose of this demo, I'm going to use an application which I'm building. It is called as Tech Talks. So you can think of it like a Tech Talks management or a event management kind of application. It has a front end which is built using, let's say, React or Angular. And then it has two services or two APIs. One is the producer, the other one is the consumer. And I also want to demonstrate the polyglot programming model, which is quite common with microservices. We don't have to stick to one programming language for the whole application. Based on the kind of workload or the kind of uh, capability that is required for the service, we can choose a different programming language, we can choose a different backend service. So in this example, I'm going to use RabbitMQ as the message broker for decoupling my producer and consumer. And for the programming languages, I would like to demonstrate .NET Core, Java, Go, and if time permits, Rust as well. So let me switch to the Visual Studio Code and see what is required for building such an application. I started building this similar application sometime in 2019. So I look at the historical code 3 years back or 4 years back, how I started this application. So let's look at the producer first. I have this code or this .NET Core API, which is having these different producer related aspects. So I take things from the environment variables related to the host name, username, password, and then there is this send messages method, which takes a list of dummy tech talks. Let's say whatever number of messages we want to generate, and then we go through the RabbitMQ client for .NET and we create a connection factory. Then we use those properties that we read from the environment variables. We create a connection, we create a queue here, then we define what are the different properties for the queue in terms of durability, in terms of auto deletion, and various other things which are required for me to have that connection established with the RabbitMQ broker or RabbitMQ server. And then I just serialize the talks that I trying to publish, and finally I do this channel.basic publish method, or I invoke this method which will actually publish the message onto the RabbitMQ. On the consumer side, the things are almost similar. We have the same three properties: the host name, username, password, to connect to the RabbitMQ, and to have the batching capability where I want to pick a certain number of messages in a batch to process. I have this additional property here which says what is my batch size. And there is a method called consume message, which again does the reverse of what we did while sending the message. So it will create that same thing, the connection, the queue, and it will have a message handler when the message is received to handle that message. On the receiving side, we deserialize the message and then we just log the contents of this, and we also sleep this for 250 milliseconds to simulate like some processing is happening. And the log just says what was the content of the message that got published. So if you look at both this producer and the consumer, the actual business logic is hardly 5 to 6 lines of code. But we have to write a lot of infrastructure code for this to publish and to consume the messages. This is for one programming language. Now imagine that I want to do this for Java, I want to do this for Go, I want to do this for Rust or any other programming languages. I will have to use the RabbitMQ client for each of that language, and I'll have to adapt my code for each of those APIs. Also, when there is a change in the API, I have to make change in each of those programming languages. It is a bit tedious. So that is where I think Dapr is a good welcome addition. What Dapr tries to do is it has all these building blocks, what it calls as components, which are available for building microservices or which are required for building microservices. So if we look at this middle part of this diagram, Dapr has these capabilities for doing service to service invocation. It can do state management. It can handle the pub/sub mechanism. It can provide us the resource binding when we want to do serverless processing, like the Lambda functions or Azure functions. We need those capabilities to have the bindings and the triggers. And from the operation side of things, or from the operator perspective, it also has things around observability where we can enable things like metrics, logs, tracing, those kind of things. It also has some additional capabilities in terms of handling the secrets and configuration as well. And from a distributed application development, it also has the capability to support distributed logs. With these building blocks, any programming language which supports HTTP API and gRPC API calling can use Dapr. As of now, Dapr has support for SDKs in Go. There is Node.js, Python, .NET, Java, C++, PHP, and Rust. And from an infrastructure point of view, where we can use Dapr or where we can deploy the Dapr-based applications, it is supported on the major cloud providers: Microsoft Azure, AWS, Google Cloud, Alibaba. Any Kubernetes distribution, we can deploy Dapr. It can also work with virtual or physical machines. So essentially, anywhere we can deploy the Dapr runtime, we can make use of this distributed application runtime. So where does Dapr fit in our application architecture? Earlier, we were making that direct call from our producer and consumer to the message broker. Now, Dapr sits in between. The communication between our message broker and the producer consumer happens via Dapr. Dapr works by means of what we call as a sidecar. So, if you work with Kubernetes, you know that sidecar is a concept where, for cross-cutting concerns, along with the application container, we have a separate container which sits side by side, and it helps us to do this additional things required for our application. It could be like logging, it could be tracing. So those kind of things is currently enabled by making use of sidecar. So Dapr works based on similar concept. It creates a sidecar, and we communicate via that sidecar to the actual underlying components. So let's see how does this get translated into the code side of things. So let me close this 3 years old code, and let's switch to the current version of the code. I will start with the .NET side of things first, and then we will also look at Java and Go APIs. So in .NET, we add a Dapr client to our dependencies in our project folder. And this is a minimal API, which is one of the recent changes in .NET Core, which allows us to build endpoints for our APIs using just one file. So the initial lines of code is what is generated automatically by the code generator for the API. The thing that I added is this support for Dapr. Since we have added the Dapr client or the Dapr dependency, it allows us to have this method on the controllers which says add Dapr. So our controller can then make use of Dapr capabilities. We also use something called as cloud events. Cloud events is a standard for working with event-driven systems. So it is trying to standardize the events, and it's trying to provide a standard for different uh, event-based systems, like the products who are building eventing capabilities, or frameworks who are giving event-driven system the support capabilities. For them, it's a way of standardizing the events, and cloud events is one of the standard which is being proposed. So Dapr uses cloud events, so it's a more of a standards based approach. And then in our actual generate method, we just have to say create a Dapr client using the Dapr builder and publish the event. There is no code or nothing which says what is the RabbitMQ connection I'm using, where is the type of the storage, and all those kind of things. All that is abstracted And all that we have to say is what is my pub/sub component name. So I need to define a pub/sub component, and on that pub/sub component, what is the topic that I want to publish the event to. The talk is the actual workload or the actual payload that I'm sending. And along with this, we are also sending a cancellation token in case we want to cancel this async event. So let's look at how do we define this pub/sub component. So if you look at the variables that I have, there is this variable named or a pub/sub component named as rabbitmq-pub/sub. This definition is the one where we configure what is our component. So as I said in the diagram earlier, Dapr has this different components that it supports. So we create a YAML file in a declarative manner to say, I want to create a type of component. We specify different metadata for that. And in the specification, we say the type of my component is pub/sub. And within the pub/sub, it is specifically creating a RabbitMQ pub/sub component. And then we define the different characteristics or the metadata which is required for connecting to that RabbitMQ. We also see that Dapr supports these modern day best practices where instead of giving a clear text connection string, it has support for secrets and things like that. So when I'm building locally or when I'm testing my application locally, I can create a local connection string using a file-based approach. And then when I go to a target environment, I can use things like Kubernetes secrets. As long as the name of my secret remains as RabbitMQ secret, I can change the implementation of that from a local file to Kubernetes secret, or I can use even like AWS KMS or Azure Key Vault to store the secret and retrieve the secret. And all the other properties that we were specifying in the code are now part of this metadata. So things like the prefetch count, which was our batch size, also the durability, all that gets externalized into this component definition file. And that was the producer part. Now, once I define this component, I can use this same component across different languages. So let's look at the .NET consumer, and then we will also look at the Java and the Go side of things. So this is the .NET consumer. Again, it's a minimal API. The initial code is all created by the code generator. On the controller side, again, I add this support for Dapr so that I can use the Dapr capabilities. And here, again, I say use the cloud events because I will be getting the load or the payload in cloud events format. And I add the subscription. Once I say map subscriber, that will give me the capability to subscribe to those events or to the topics. So my process method, which is consuming that particular event, now has attribute or additional method which says with topic. This is the pub/sub component name, and tech talks is the topic name. With this one line of change, without writing any code to connect to RabbitMQ, I'm able to consume those messages, and rest of the part remains the same, where we have that slight delay or we put a thread to sleep for a short period of time, and then we log the actual contents of the message. So here we can see that all that infrastructure level plumbing code is taken out of the actual business logic, and we can focus as developers purely on writing our application code. By externalizing the configuration to a component, we can reuse that component across different languages. So the same component which I defined or which I showed you a couple of minutes back, let's say if I were to use Java, how would I do that? So here is the Java producing a Spring Boot application here. And I've added again the dependency to Dapr client in my pub.xml file. Once I import the Dapr client and Dapr client builder on my REST controller, I again get this capability to say, I want to create the Dapr client. If we skip this part, which is generating those number of messages or the tech talks, the actual publishing is again same like what we saw in .NET. We call the publish event method here. We pass the same component name and the topic name along with the payload. On the consumer side, again, I add the Dapr dependencies, and we get this topic and the cloud events as the types to import. So using this topic annotation in Java, I specify component what topic I want to subscribe, and I will be able to subscribe to that. If we were to go to the Go side of things, it is again similar. We have the Dapr or the Dapr client. We define the component name and the topic name. We again do the publishing part. So if we again skip all this part, which generates the dummy tech talks, to publish the context, what's the component name, topic name, and whether it's .NET, whether it's Java, whether it's Go, and when we look at Rust in future. We have to understand how to publish the event using the Dapr SDK. We don't really have to understand, or we don't really have to know how to connect to the underlying infrastructure. I won't show the consumer in Go because it's almost the same. So with that, I'm going to switch over to the actual demo, and I would request you to just scan this, which will help me to generate the workload. So before we go there, let me show you the RabbitMQ UI, where I've deployed this application to Azure Kubernetes Service or AKS. And currently there are messages this time. This is the Tech Talks consumer queue where I'm publishing those messages. And if you scan this QR code, it will generate some workload on that. And we will see that the messages are getting consumed. So I will do it on my side, and you can also scan the QR code and help me generate some workload. So here we can see that some messages have been pushed to the queue, and in a short while we will see the number of consumers consuming this. I have a auto scaling enabled for this consumer, and if you have seen one of my earlier talks where I talked about KEDA, which does the auto scaling, so I'm using KEDA for dynamically scaling these consumers based on the number of messages which are to be consumed. So while this is getting consumed, it will take maybe a minute for the consumer to kick in because of the timer, which looks at how frequently it has to do. Let me go into the Octant, which is the visualizer for Kubernetes cluster. So we can look at the different pods here, and we can see that the consumer pods are already coming up, and there are a couple of producer pods here. We have Zipkin and RabbitMQ in this. So I will go into one of this consumer, and we can see the log messages. So here we can see that those messages are getting consumed in real time. We can see the contents of that log, whatever we were showing. So again, if I switch back to the management UI of RabbitMQ, we can see that right now there are 8 consumers which have come up, and we have close to 7,300 plus messages which are to be processed. So that is how Dapr is able to communicate between the producer and consumer. One thing I did not show here is the part related to building the Docker image and publishing that to a container registry. If you would like to understand about that, you can head over to my YouTube channel, and you can see the current series which I'm doing, which is called as the Cloud Native Ninja, where I'm doing some of these aspects. And I'm showing how to containerize the application, how to use Dapr, what are the features of Dapr. All that in much more detail is available on my YouTube channel. So I suggest that in the interest of time, I did not show that how to build the container image, how to deploy it or how to publish it to the container registry. So I assume that you understand that part, since we are deploying the application to Kubernetes in this case, those prerequisites in terms of building and pushing the container images to one of the container registry. So if you don't know, I suggest that you have a look at these things. So where I've talked about containerizing the Spring Boot, then how to publish these images, how to use Docker Compose, then how to use Dapr or how to get started. What I showed here was Dapr in a target Kubernetes environment, but you can also run Dapr locally on your machine. As a developer, you can test everything locally before you even push the container images to your container registry, or you push the code to your code repository. So in these videos, I have explained how you can start using Dapr or how you can get started with Dapr. In terms of the security aspects, I would say I showed how to handle the secrets. So if we look at this again here in the code, let me go and see where do we have our secrets. So in my Kubernetes environment, I have a secret which is created to connect to the RabbitMQ. So instead of again having the clear text credentials, I'm using my target environment, which is Kubernetes provided secret capabilities here. And I hope the list comes up soon. So I've created a Kubernetes secret. And what I was showing you earlier was, while that octant loads up, let me switch back to the file and show you. So in my local environment, I was using this RabbitMQ, which was a local file. So if you look at it, it says secretstore.local.file, and I'm referring to a secrets.json file, which is available locally on my machine. But when I deploy this to Kubernetes environment, I use the Kubernetes secret. So in my Dapr components, if we look at the pubsub component here, we can see it is referencing the secret key ref. The name is again RabbitMQ secret, and this is created as part of my RabbitMQ secret. So this is how I create a secret in my Kubernetes environment, and I refer to that. So again, from the developer experience point of view, we see that Dapr supports these best practices, and it enables you to really build applications which are portable. You can use the same code, same concepts across different environments. There is some problem with the octant, and I'm not able to show the or list the secrets here. But if it was able to show you, you would have seen that secret here, and that secret is the one which is getting used in the actual connection of the component. Dapr also provides a dashboard. So if we go into the services, again, I hope, yeah, services is working. So it looks like some problem with the octant there. I have under the Dapr system, there is a Dapr dashboard which is provided by Dapr. And if I do a port forward, and if we go to this Dapr dashboard, we will be able to see which are the applications which currently are making use of Dapr capabilities. So we have the RabbitMQ producer and consumer, which are using Dapr. We can also look at the components, which are Dapr components. So we have the pubsub component, which is created. We can look at the actual configuration of that. So whatever is there in our YAML file gets converted into a Kubernetes type of an object, and we can see that using Dapr. We can also look at the different configuration. So if you remember earlier in that slide, I was showing that Dapr has support for distributed tracing, it supports matrix. So things like that, we can configure this, and On this Kubernetes cluster, I have configured Zipkin as my distributed tracing mechanism, or I can use Zipkin to do the distributed tracing. So if I go into the Zipkin UI, we can see what are the different services and what are the different traces. So I have only two services here, the RabbitMQ producer and the consumer, which are using Dapr. So using that, again, we can go down and we can see in real time how the services are interacting. In our case, it is only two services, but in real life, you might have 10 or 15 or multiple services, and you will be able to see the communication happening between these different services using this distributed trace. We can also find if there are some problems using the trace feature. So here you can see what is happening, like RabbitMQ producer, it's publishing the events and how much time it's taking. Like in our case, it's taking around 250 or 260 microseconds. In some cases, it is 160. This is slightly higher compared to normal. Usually, it takes much lesser than that. But because I have this trace enabled, I can quickly see that, okay, this is the amount of time it's taking to publish an event. And probably that's the reason. Maybe my producer and consumers, they are not running as expected at the full speed. There could be some problem, network lag or whatever it is. I'm able to visualize that in a very quick manner. And in my code, I do not have anything related to Zipkin, or I do not have anything related specific to this. So if you look at, let's say, uh, one of this, let's look at the producer on .NET side. And if I look at what are the dependencies I have, you see I have core or ASP.NET Core Dapr dependency. I have some OpenAPI ASP.NET Core bogus. There is nothing related to Zipkin. All that is coming is out of the box with Dapr. And with just few annotations, which is a way for specifying external things on Kubernetes, I'm able to enable these cross-cutting concerns. So if I look at, let's say, producer deployment, if I want to use is in my Dapr IO, in the configuration, enable Zipkin. With this, without any change to my application code, I am able to get the distributed tracing capability. Same thing goes for Matrix. I can enable Matrix for my application just using these annotations. So if you want to learn these kind of things, you can go over to the Dapr site, dapr.io, and we are talking about observability and tracing, right? At the moment, I showed the Zipkin part, but they also have support for Jaeger, New Relic, OpenTelemetry. If you would like to use any of this, you can go through the documentation. The documentation is very well uh, structured. You can follow this. You can see how to do it in your local environment as well as in your Kubernetes-based cluster. So self-hosted mode is local. If you want to test it locally, you can follow this. And what I've done is I did the Kubernetes setup. So using this declarative configurations and things which are, uh, when we develop microservices, we need all these capabilities like service to service invocation, we need distributed tracing, all these kind of things. They are part of more of a infrastructure layer or infra component. They shouldn't be really part of the application code. Application developers should focus on writing the business logic, and that is where Dapr enables us to have all these components which are required uh, as part of the cross-cutting concerns, just as configurable things. And these are plug and play. So if I don't want Zipkin, if I don't want distributed tracing for the application, I can remove this line number 25 and my application will still continue to work as is. The application doesn't even know that it is being traced. So with that, let's switch back to the slides. This is what we saw during the demo. I had the Azure Kubernetes Service or AKS cluster. For this demo, I was not using the Azure Container Registry. Actually, the images, they were deployed to Docker Hub. So probably I should update this diagram. But in my earlier demos, I used to publish my container images to the Azure Container Registry. So you can use any container registry, in fact, anything that is OCI compliant. Then we deploy it on the Azure Kubernetes service. everything, the producer, consumer, the Dapr itself, and the RabbitMQ, all these are running inside the Kubernetes cluster. To install Dapr, I'm using Helm. So Helm is like a package manager for Kubernetes-based application. It is available as part of a Helm package, and we can deploy Dapr using Helm on any Kubernetes cluster. If we are talking specifically about Azure Kubernetes Service, Dapr is available as an extension, which makes it even more easier. So we don't have to deploy Dapr as part of Helm. I can just enable the extension, and it is available in my AKS cluster. So this is what we saw, or this is how Dapr works. Dapr has these different components which work internally. There is the sidecar component, which is the main component, which sits along with the actual application code, but it also has things around the actor placement or for placing the objects. It has the runtime for injecting different capabilities. It also has MTLS for certificates, and it also has a operator model. So if we are running in, let's say, high availability scenario, Dapr can be deployed in multiple clusters in high availability scenario. So it supports operator model, and it can be deployed on any cloud, as we saw earlier. Now, when it comes to the Dapr components, we looked at only two of them, I would say. One is the secret part, and the other one was PubSub. But Dapr has support for these data stores bindings. And if we look at, as of today, there are more than 100 different components supported. So for State Store, it supports AWS DynamoDB, there is Cosmos DB support, Firebase, Redis, Cassandra. PubSub, we looked at RabbitMQ, but there is support for Redis, Azure Service Bus, AWS SQS, and GCP PubSub. And same way, for each category, you see that there are different compatible services. This could be the native cloud services like AWS S3, or it could be third-party services like Kafka or Twilio, which are not part of the public cloud providers, but provided by someone like Confluent or others. So with that, I think what Dapr provides is this very rich capability, which is required for building today's modern day cloud native microservices based applications, where we can easily switch between these components as long as the component name remains the same. If I look at the PubSub itself, say tomorrow I want to change from RabbitMQ to use AWS SQS, or I want to switch to Redis, my code doesn't have to change even a single line. Only thing that I need to change is that component configuration and the metadata, which is required for the code to connect to that particular component. So if I want to connect to Redis, I need to provide the metadata for connecting to the Redis cluster or Redis server, and same thing for the others. So with this, it makes the application development really, really easy. I think if you are building SaaS-based products and services, and you don't have control over what kind of infrastructure is used by your customers, this could be a very good addition to your toolkit. Where if you want to deploy to AWS, you can choose AWS-based services. If you are deploying to Azure, you can choose Azure-based services. So your time to market can be reduced quite a lot by using something like Dapr. So why do we use Dapr, or what are the main reasons you might want to use Dapr? We covered, I think, initial 4 or 5 blocks where it supports any language, any framework. It can be deployed anywhere. It provides all these building blocks that we saw, the data, then the PubSub, service to service communication, security, secrets, all these kind of things, multiple hosting environments. Language support as of now is for C++, Go, Java, JavaScript, .NET, PHP, Python, and Rust. There is also built-in support for some frameworks like commonly used ASP.NET Core framework, Spring Boot. If you are on Python side of things, then Flask, and on the JavaScript side, Express is supported natively. And it is designed for operations. So as we saw with the help of the telemetry part, where we use this Zipkin and to identify things like that, Dapr has this support even for the operations. It is not just a tool for developers. It also looks at end-to-end application deployment side as well. And it is useful in terms of scaling or improving the operations part of the microservices. So, in summary, what Dapr tries to do is it helps us to simplify the microservices development and deployment. It abstracts all the underlying functionality for connecting to your infrastructure resources or services by creating these components. And the components, they are exchanged or they are swappable. Within the same layer, we can swap the component very easily. It also supports best practices for cloud native application development. So, as we saw with the secrets, that was one example I would like to highlight where it enables developers to follow the best practices, whatever is currently used. We don't have to do something completely different to integrate with Dapr, and it helps us to build these portable apps. We can deploy them anywhere on our laptop, public cloud, private cloud like OpenShift or other Kubernetes based environment, hybrid cloud, and multi cloud scenarios as well. We didn't see the serverless part here, but because it has support for that, the triggers and bindings, Dapr can also be used to build serverless applications. And as we saw already, it helps us to implement the observability based features for monitoring the applications. So here are some references. If you would like to know more about Dapr, the first place obviously is to go and look at the dapr.io site where all the Dapr related resources are available. There is also quick starts on GitHub. The examples are quite extensive in my opinion. At least to get started, it's quite easy to follow the documentation, and you can go through these different things like how to do secret management, PubSub, how to set up Dapr in your local, how to deploy Dapr on Kubernetes. And I also did a talk with one of the guy called Azure, the Arterio, where we talk about how to use Dapr in a serverless Azure container apps. So if you are interested, you can also have a look at this. And I already talked about this Cloud Native Ninja series, which is built based on Dapr. So that's on my YouTube channel. With that, I would like to conclude this session, and all that I showed is available on GitHub. It's part of my GitHub repository. You can scan this QR code, or you could go to my GitHub Nilesh Gule and Cloud Native Ninja repository, which has all the source code. The slides are already published on SlideShare and Speaker Deck if you would like to reference them for future. Thanks once again for joining this session, and until next time, code with passion and strive for excellence. If you have any questions, I'm happy to take them.
Sure, I think there are two folks who are ready. There was an
Yeah.
in-person
Good.
meetup happening right now,
Okay.
and there was an online webinar which was happening, and these two folks have some questions. So yeah, you
Sure.
can introduce and you can ask some questions here.
Okay, Amit Gira this side. I have one quick question. Is like you mentioned, this heterogeneous migration support you do.
Talk a little louder.
Okay, does it support heterogeneous within a same flavor of engine or within a different flavor of engine, like from RDBMS to RDBMS or NoSQL to RDBMS also?
It's in the same quadrant, I would say. So if we go back, let me pull up that slide here. When it comes to, let's say, data store, if you want to use Dapr, right now you can use it with any of this. So AWS DynamoDB, Azure Cosmos DB, Firebase, Redis, or Cassandra. So if you are using currently Redis and you want to switch to AWS DynamoDB or you want to switch to Cosmos DB, you can use the component for this and you can switch between this. So if you look at this row, whatever is in that row, you can switch one for the other.
Okay, means
But you can't
NoSQL
switch
to
from, let's say, DynamoDB to, if you want to switch to Kafka. That's not possible.
okay, within same flavor.
Yes, within same flavor.
Okay,
You
got
know,
it.
this
Thanks.
flavor word that makes a lot of engineers' life much more easier and faster. I think there's one more. I think you have to ask the question.
Yeah, I just had a quick question. Can I integrate Dapr with AWS API Gateway?
There is nothing specific in Dapr which says you can't integrate with API gateway, because if you look at Dapr, it works in a normal way. It just enhances your communication between the infrastructure layer or these different cross-cutting concerns like observability or configuration or distributed log. So your AWS API would still be connecting to some service or microservice, right?
Yeah.
Yeah, that part remains the same. There is no change in that.
Okay.
All the things that are being shared in the slide here. I think that was great. I think you have any other question? Alright, go ahead. Like if you have anything, ML, data engineering, whatever it is, he's the best person to reach back to. And yeah, I think one question that was asked by one person that I was just talking here, like there is always a security layer impact that is happening, and there is obviously that definition of security is always supposed to be asked. So how is the security practices defined through Dapr? Like how is it affecting the people who are migrating from one another? So is the security practices taken in mind here?
It has support. So it's up to the engineer what kind of security they want to use. So I showed the secrets part, right? So let's say you want to use a secret manager for storing your secrets. Now, what I showed here was to store the connection string as a Kubernetes secret. But Kubernetes, again, is just a base 64 encoded secret, right? That's not secure to uh, encrypt your secrets and store it in Kubernetes cluster. So let's say you want to use Azure Key Vault. So in that case, Dapr will give you that component where you can connect to the Azure Key Vault and you can retrieve the secret, and that secret can be available to your deployment or to your pod. And what this allows us to do is, in future, again, I don't have to have a hard dependency on the Azure SDK, or I don't need the hard dependency on HashiCorp Vault SDK, for example, if I'm using Vault. By using Dapr, it will give me that abstraction. So I can easily switch between any of these secret provider. Does that answer your question?
Yes, it answers most of my question. I think there's a lot that we have to uncover with respect to cloud native. There's a cloud native ninja series from his side, the cloud native, of course, a lot of series coming from our side. So do reach back to us at any given point of time. Like we are happy to help. We are happy to help you migrate. We are happy to help you adopt the right things. And thank you so much, sir. This was such a nice session. I enjoyed a lot. I enjoyed a lot by seeing the demos on the same .NET. That's your place where you always started as an engineer. And yeah, it
Yeah.
was perfect. Thank you so
Thank
much,
you.
sir.
It was my pleasure. Thanks a lot.
Sure, folks. So this is the time we end the broadcast. We go for the next demos as well. So until then, see you soon. Bye.
Bye bye.